Okay, where do you want me to start?
12. Let's just start at the beginning.
Nope, that's too easy.
16.
16. Nope, too easy.
Is that y equals x or y equals
18. 18.
No.
16 is three functions.
16.
Hold on, three functions with range, all real numbers. Range is the y values, right? So they just want you to find three functions that go down forever and go up forever.
So
So
y
for
equals
example,
x.
y equals x is an easy
Y
one.
equals x cubed.
Y equals x cubed is another one, and then you just have to find one more. Okay, 17 and 18.
y goes ln of x.
Yeah, that'll work too. 17 and 18 are the tricky ones because it has this notation in here that you've never seen before. So it was really nice of me to assign you that on the first day without explaining it. Okay, well, I appreciate that. All right, number 17, the way that translates into English is the limit. That's what this stands for, is limit. As x approaches infinity is infinity. And so what that means is as the x's get bigger, as they go towards infinity, the y's get bigger also. They go towards infinity as well. Okay? And so this one says the three functions that do not have end behavior that way. Okay? So give me a function that does not, when the x's get bigger, the y's get bigger also. What? Sine of x is one of them because that one goes up and down and up and down and all around. Cosine of x is another one for the same reason. Nice. And then 1 over x is the third one because that one, as x approaches infinity, what does y approach? And what does it get closer and closer and closer to? 0, right. So for that one, you would write the limit, good morning, as x approaches infinity of 1 over x is 0. Hi. Patricia, is that, yes, that's you. All right, come on in, have a seat. Just wherever you want. This is Patricia. We're all friendly here. Come on in. There you go. Okay, so does that make sense? Oh, I should probably get your book. And Patricia, I have to apologize. The books are in really bad shape. Okay, what next? So we are on, we're going over some questions from page 105. What next? 18?
Yeah.
Okay, 18 though, now you know because we learned it on 17, the two functions with end behavior, the limit. Yep, as x approaches negative infinity, so that means the x values are getting smaller, equals negative infinity. So now we have to go the other way, and we're looking for functions when the x values get smaller, the y values get smaller too. 1 over x does not work because as the x values get smaller, the y values get closer to 0. Nope, because we want ones that do have this behavior, not that don't. X cubed, because if you look at them, the things down here, they're both going the same direction. The opposite value goes the other way, it goes up. We want the x's to go to the left and the y. Yep, y equals x is a 1. Is there another one or were there only 2? There's only 2? Okay. So
yeah, this is easier.
X cubed and y equals x. Yeah, sorry, there's just a little notation in there. Okay, is that it? Those are the main things, right? Oh, the other thing that somebody asked me about, or a couple of people asked me about, number 14, the two functions with infinitely many local extrema. What the heck is that? Extrema is plural of extremes. Okay? So infinitely many extrema means infinitely many high points or low points. Okay? So which ones have an infinite number of high points and low points? Sine and cosine, which goes up and down, up and down, up and down, up and down.
20 I feel like sine and cosine too.
The two functions whose graphs are, yeah, that's also sine and cosine.
What was the other one that was sine and cosine? 19?
No,
14, yes. 19, the four function, these graphs look the same, but
Me
it
too.
turns upside down and flips about the y-axis.
Let's turn it in. 19.
Yeah, I think x cubed, y equals x.
Like 1 over x?
1 over x, yeah. Oh, sine of x, that works for it too?
Are you sure? When you flip it,
No, because
when it changes to cosine.
No, because it's still going to cross at 0. Because we're not shifting it up or down. So yeah, I think that works. And I believe that's another way of describing an odd function.
You just threw us right in.
Threw you to the wolves right off the bat. They weren't, but you guys responded. All right, turn
We
to
pulled Liam Neeson to New York.